Logistic regression is used when a research study has a categorical outcome rather than a numeric one. It exists because some research questions are not about average scores, but about whether something happens or does not happen. In earlier analyses like ANOVA, ANCOVA, and MANCOVA, the outcome is numeric and the focus is on comparing group means. When the outcome is categorical, such as yes or no, present or absent, completed or not completed, comparing means no longer makes sense. Logistic regression is used instead. The decision rule is straightforward. If the outcome variable is categorical and the research question is about likelihood or occurrence, logistic regression is the appropriate analysis. The choice is driven by the type of outcome, not by how many predictors are included. In logistic regression, the outcome is a category rather than a score. Most commonly, the outcome has two categories such as 0 and 1. For example, 0 might represent not completed, and 1 might represent completed. Logistic regression models the likelihood of being in one category, rather than the other. Instead of asking how high or low a score is, it asks how likely an outcome is to occur. Most logistic regression examples use two categories, but the same idea can be extended when outcomes have more than two categories. When the question shifts from how much to how likely, the analysis must shift as well. To anchor the logic, consider a running example. Imagine a study examining whether participants complete a training program. Program completion is coded as completed or not completed. Researchers want to know whether participation level and prior experience are related to the likelihood of completing the program. Because completion is a categorical outcome, logistic regression is used. This leads to an important clarification. Logistic regression is not asking whether one group has a higher average score than another group. It is asking how predictors are associated with the likelihood that the outcome occurs. The focus is on probability, not means. Predictors in logistic regression are variables thought to be connected to whether the outcome happens. A predictor is any variable you think might be related to the outcome, such as group membership, a score, or a background characteristic. Predictors are selected based on theory, prior research, and the logic of the study, not simply because they are available. Logistic regression can include one predictor or several predictors at the same time. Including multiple predictors allows researchers to examine how each predictor is associated with the outcome while accounting for the others. Note that a formal question or hypothesis would say predict, but in this case we are using associated since the word predictor is used as a generic term. Accounting for a predictor means the analysis estimates the relationship between one predictor and the outcome while holding the other predictors constant. The research question for logistic regression must reflect this logic. It should focus on association and likelihood rather than difference in means. A simple template is predictor associated with the likelihood of categorical outcome? Using the running example, a complete research question would be, is participation level associated with the likelihood of program completion, after accounting for prior experience? Logistic regression relies on assumptions, and they should be considered one by one. The first assumption is independence of observations. Each participant contributes one outcome that is not dependent on another participant's outcome. If outcomes are influenced by grouping the study does not account for, the model can look more confident than it should. The second assumption is that the outcome is categorical and coded clearly. Logistic regression requires a categorical dependent variable. For the common binary case, the study must clearly define what counts as 0 and what counts as 1, and that coding must be consistent for every participant. The third assumption is that predictors are meaningful and measured well. Predictors should be included for a reason grounded in the study logic or prior research. If predictors are poorly measured or conceptually unrelated, results can be unstable or misleading. The fourth assumption is that predictors are not extreme duplicates of each other. If two predictors are essentially measuring the same thing, the model has trouble separating their effects. This makes estimates less stable and interpretation less trustworthy. The fifth assumption is that there is enough outcome information to support the model. Logistic regression needs enough cases in each outcome category to estimate relationships. If one category is rare or the sample is small relative to the number of predictors, results can become unstable. The sixth assumption is that numeric predictors relate to the outcome in a consistent way. In plain language, as a numeric predictor increases or decreases, the likelihood of the outcome should change in a smooth, consistent pattern. If the relationship is highly irregular, the model may not represent it well. Interpreting logistic regression results focuses on direction, strength, and context. Direction asks whether a predictor is associated with a higher or lower likelihood of the outcome. Higher likelihood means the predicted probability of the outcome increases, while lower likelihood means the predicted probability decreases. Strength asks whether that relationship is meaningful in practical terms, not just statistically significant. Context reminds the reader that relationships are estimated after accounting for other predictors in the model. A clear interpretation sentence structure is: the results indicated that predictor was associated with a higher or lower likelihood of outcome, after accounting for other predictors. For example, the results indicated that higher program participation was associated with a greater likelihood of program completion, after accounting for prior experience. Effect size in logistic regression is about how much the likelihood changes, not just whether it changes. Logistic regression commonly expresses effect size using odds ratios. An odds ratio greater than 1 indicates higher likelihood of the outcome as the predictor increases, or as the group changes to the coded category. An odds ratio less than 1 indicates lower likelihood. The farther the odds ratio is from 1, the stronger the relationship. Odds ratios close to 1 indicate a weak relationship even if the result is statistically significant. Follow-up interpretation in logistic regression does not involve post hoc tests like ANOVA. Instead, follow-up focuses on clearly describing the pattern of results. When predictors are significant, researchers often compare predicted probabilities across groups or across meaningful values of a predictor to show what the results mean in practical terms. Power in logistic regression refers to how likely the study is to detect a real relationship when one exists. Power is stronger when the sample size is larger, when there are enough cases in each outcome category, and when predictors are meaningfully related to the outcome. Power is weaker when samples are small, when one outcome category is very rare, or when too many predictors are included for the amount of information in the data. Robustness refers to how well logistic regression performs when data are not perfect. Logistic regression does not require normal distributions, and does not rely on mean comparisons, which makes it well suited for categorical outcomes. However, it becomes less stable when outcomes are extremely unbalanced, when predictors overlap heavily, or when the sample size is small relative to the number of predictors. Trustworthiness in logistic regression comes from alignment and restraint. Results are more trustworthy when predictors are theory-driven. Outcome coding is clear and consistent. There are enough cases in each outcome category, and conclusions stay within what the design supports. Trustworthiness is weakened when predictors are chosen only because they are available, when important background factors are ignored, or when results are written as causal claims without a design that supports causation. It is also important to be clear about what logistic regression does not do. Logistic regression does not compare group averages. It does not explain why an outcome occurs. It does not establish causation unless the research design justifies causal conclusions. Logistic regression fits into a research study when the research question, outcome, and predictors align around likelihood rather than mean differences. It is especially useful in applied research settings where outcomes are naturally categorical, such as retention, completion, diagnosis, or participation. When the outcome is categorical and the question is about whether something happens, logistic regression is a clear, robust, and defensible analytic choice.